arc extension using low resistance arc interruption method. So there are four methods in it also. Like first is by rapidly increasing the distance between the contacts, high pressure, cooling or blast effect. So these are four ways for the arc extension using low resistance arc interruption method. Explain low resistance or current zero interruption in circuit breaker. So this type of arrangement is used in the AC circuit breakers. In this, the arc resistance is kept low until the arc current becomes zero. The arc extinguishes when the current becomes zero. It is seen that the arc does not strike again even if the value of the restriking voltage is more, because the rate of dielectric strength buildup is high. There are positive ions and negative ions in the region around the contacts, so the dielectric strength is low. So the arc strikes again when the contact voltage increases. But if immediately after the current zero, the dielectric strength in the region between the contacts increases rapidly compared to the rate of rise of the striking voltage across the arc does not strike again, means the arc is interrupted. Increase in dielectric strength of the medium can be done by two different methods. One is by converting the ions into the neutral molecules to take their place, and this can be done with the help of the recombination of the molecules or the ions in the region between the contacts. Second method is by removing the ions and the neutral molecules to take their place. So we are allowing the neutral molecules to take the place of the ions. Now process of deionization of the medium can be done by the following methods. One is by increasing rapidly the distance between the contacts. So the dielectric strength depends upon the distance. The dielectric strength increases when the distance between the contacts increases. So the distance between the conducting plates or the moving contacts and fixed contacts increases. So the distance between the contacts is increased rapidly. The dielectric strength increases rapidly. High pressure. When the pressure around the arc is increased, the density of the particles forming the arc increases and the deionization process increases rapidly. So the dielectric strength increases quickly or rapidly. Now cooling. The process of deionization becomes quick if the arc is cooled. So the increase in the dielectric strength becomes faster or the quicker one, and the cooling means the cooling of the arc takes place, and this will allow the dielectric strength build up rapidly and allow the arc to increase quickly. Blast effect. In this method, the ionized particles of the arc removed rapidly by the flush of gas or oil in the medium. So the ionized particles are removed and the space is occupied by the neutral molecules. So there is a rapid increase in the dielectric strength. So these are some methods to increase the deionization process and allowing the quenching of the arc in the medium at the zero current interruption time. So this is how the low resistance or current zero interruption in circuit breakers takes place. Explain opening time of a circuit breaker. So relay is operated when the fault occurs. Trip coil of the circuit breaker is energized through the contacts of the relay. Due to this, the operating mechanism activates and the contacts open, means the fixed contact of the breaker in the line opens up and disconnect or isolates the faulty and healthy sections. Now this process of opening the contact is not instantaneous, but there is a time lag in it, because moving contacts are fixed in the fixed contacts up to a certain depth. This is called the depth of the engagement or wipe. Contacts take certain time to cover this distance. The time required for this is called the opening time. So the opening time can be defined as the time taken from the instant the trip coil is energized to the instant the contacts are separated, that is moving contacts are separated from the fixed contact, is known as the opening time. So this is how the opening time of a circuit breaker can be explained properly with a figure. Define depth of engagement or wipe of circuit breaker. So the process of the opening of the contacts is not instantaneous, but there is a time lag in it. So moving contacts are generally inserted into a certain depth of a fixed contact, like fixing this. So whenever the opening or the energization of a coil is there, the contacts are separated. So the depth up to which these moving contacts are inserted into a fixed contact is called the depth of engagement or wipe. Define opening time and arcing time of a circuit breaker. So the time taken from the instant the trip coil of a circuit breaker is energized to the instant the contacts are separated is known as the opening time. Whereas the time taken from the instant the contacts are separated to the instant the arc is extinguished is called the arcing time. Explain total breaking time of circuit breaker. So the total breaking time can be defined as the sum of the opening time and the arcing time is called the total breaking time. Now the opening time can be defined as the time taken from the instant the trip coil is energized to the instant the contacts are separated is known as the opening time. Now the time taken from the instant the contacts are separated to the instant the arc extinguished is called the arcing time. And the complete time of the trip coil energization to the arc extinction is called total breaking time. So this is how the total breaking time can be explained or defined. Define arc voltage and recovery voltage with reference to circuit breaker. The voltage across the moving and fixed contacts during the arcing period is called arc voltage. And the normal 50 Hz frequency voltage across the contacts of the breakers when the arc quenches means arc completely extinct is called the recovery voltage. So this is the definition of arc voltage and recovery voltage with reference to circuit breaker. Define restriking voltage and active recovery voltage with reference to circuit breaker. So the transient voltage across the contacts of the circuit breaker, that is the transient momentary high value of the voltages, means first 1 to 5 cycles or 1 to 8 cycles, the transient voltage across the circuit breaker contacts during the arcing period when the arc current becomes 0 or near to 0 is called restriking voltage. The value of this restriking voltage is very high. The magnitude is like twice the value of the maximum voltage is available. Nearly so very high voltage available during that arcing period time is known as restriking voltage. Now what about the active recovery voltage? The instantaneous value of the recovery voltage when the arc quenches means arc completely extinguished at that time, the instantaneous value of the recovery voltage at this context of circuit breaker is known as active recovery voltage. So this is the way of defining restriking voltage and active recovery voltage with reference to circuit breaker. Explain restriking voltage in circuit breaker. So the voltage across the arc in the transient state when the arc current becomes 0. So at that time, because of the oscillatory circuit is formed due to the inductance L and the line up to the fault current and the capacitance of the bushings of a circuit breaker to the earth. So oscillations are produced due to this LC tank circuit formed because of inductance of the line and capacitance across the bushings of the circuit breaker to the earth context. The natural frequency is f of n is equals to 1 upon 2 pi under root of LC, that is series resonance natural frequency. This oscillatory voltage superimposes on the normal voltages. This transient voltage is called the restriking voltage. You can visualize in this figure, this is the arc voltage. You can see this is the arc voltage which is in phase with the fault current. This both are in same phase because of the inductive nature. At this time, when current strikes to zero, this is the voltage, that is the restriking voltage. The interruption of the current in circuit breaker depends upon the restriking voltage, because we saw that if the restriking voltage rises with the rate more than the rise in the rate of the dielectric strength of a medium, then arc still persists or will continue for the next half cycle. But if the rate of rise of restriking voltage is lower than the rate of rise of building up of a dielectric strength of a medium, then arc will extinguish, arc will not strike again, and this is called, that's why, the restriking voltage. And the statement that we have given for the rate of rise of restriking voltage or rate of rise of building up of a dielectric strength of a medium is based on the Slapian's theory. The transient voltage across the contacts in circuit breaker during the arcing period, when the arc current becomes zero or it is near zero, is called the restriking voltage. This is the definition of the restriking voltage. So this is how the restriking voltage in a circuit breaker can be explained. Define recovery voltage for circuit breaker. So in circuit breaker, the arc is produced when the contacts are separated at the current zero. If there is sufficient increase in the dielectric strength of the medium, the arc quenches and the current of the circuit is interrupted. So the normal 50 Hz frequency voltage across the contacts of the circuit breaker when the arc quenches completely is called the recovery voltage. Explain recovery voltage in circuit breaker. So in a circuit breaker, arc is produced when the contacts are separated, that is, the fixed contact remains there and moving contact separates from it. At the current zero, if there is sufficient increase in the dielectric strength of the medium, the arc quenches and the current of the circuit is interrupted. Immediately at the instant the current interrupts, there is high frequency transient component in the voltage across the contacts which die out, and the voltage across the contacts becomes normal 50 Hz and it becomes equal to the system voltage itself. This voltage is called the recovery voltage. So the recovery voltage can be defined as the normal 50 Hz frequency voltage across the contacts of the circuit breaker when the arc quenches completely is called the recovery voltage, and its value is approximately equal to the system voltage. In a multi-pole circuit breaker, the voltage of the two phases is called the recovery voltage VR. Here you can see this VR. This voltage across the two phases is called the recovery voltage, while the voltage across the same pole is known as the recovery voltage component VRC for the multi-pole circuit breaker. So this is how the recovery voltage in a circuit breaker can be explained. List out the factors on which reactive recovery voltage depends. So in the instantaneous value of the recovery voltage when the arc quenches completely is called the active recovery voltage, and it depends on the following factors like the power factor, the short circuit current wave asymmetry, and the condition of the circuit. Define rate of rise of restriking voltage. This question is asked many times in the examination and in viva examinations. So it is defined as the arc is produced when the contacts of the circuit breaker are separated. So the voltage across the arc is in transient state when the arc is quenched and the arc current becomes zero or nearly zero, and its value of the voltages across the contacts is equal to twice the value of maximum, that is 2 em. This is called as restriking voltage. The rate of this increase is known as the rate of rise of restriking voltage. So if we want to calculate it, so triple RV can be calculated using this following equation, that is rate of rise of restriking voltage is equals to peak value of the restriking voltage divided by, or in the denominator is time between 0 to peak value in microseconds. So this is how we can define rate of rise of restriking. Rate of rise of restriking voltage, triple RV. So the arc is produced when the contacts of the circuit breaker are separated, that is the moving contacts are separated from the fixed contacts. The voltage across the arc is in the transient state when the arc is quenched and the arc current becomes zero or nearly just zero, and its value is just equal to the twice the value of the maximum value of the voltage. This is called as the restriking voltage, and the rate of the increase is known as the rate of rise of restriking voltage, and it is given as the formula like this. Triple RV can be found out like peak value of the restriking voltage divided by the time between 0 to peak value in microsecond. The rate of rise is calculated with this equation. So this value is called the average triple RV. There is one more term regarding this, that is called as the maximum rate of rise of restriking voltage. It is expressed by the maximum slope of the voltage curve, where the voltage rise is the maximum one. If the rate of rise of restriking voltage is more than the rate of rise of buildup of dielectric strength of the medium, then arc strikes again, and if the rate of rise of medium or building of a dielectric strength of a medium is more than the rate of rise of restriking voltage, the arc cannot strike again. This statement is the Slapian's theory statement. This value of triple RV depends upon recovery voltage, that is the value of the voltage when the arc is just quenched at the natural zero current value, or the forcefully when the arc current becomes zero. At that time, the oscillation of the frequency or the natural frequency of the oscillation can be found out by Fn is equal to 1 upon 2 pi under root of LC, that is series resonance frequency. When the short circuit occurs near the bus bars, the value of L is so less, so the natural frequency of oscillation becomes more, and hence the value of triple RV becomes much more. So this is how the triple RV, that is rate of rise of restriking voltage, can be explained properly. Explain resistance switching in circuit breaker. So oscillations of high voltage magnitude are produced when the inductive current or a capacitive current is broken or are broken, that is chopped. This may damage the system. So to prevent this, a resistor is connected across the contacts of the circuit breaker. A bypass resistor across the contacts of circuit breaker is connected. This is called resistance switching. The contacts of the circuit breaker open and the arc is produced across the contacts, that is the moving contact are separating from the fixed contact when the fault occurs. So as the resistance R is connected across the contacts of the circuit breaker, some part of the arc current flows through that resistor. So the value of the arc current decreases and the rate of deionization of the path increases. So the arc resistance increases, and hence the value of current flowing through the shunt resistance R increases continuously. So this shunt resistance prevents the increase of restriking voltage, and it increases exponentially with the time. So, and it is increasing up to the value of recovery voltage. Hence the value of R should be selected such that the circuit becomes the oscillatory or critically damped type. Due to the resistance switching, there is decreasing rate of rise of restriking voltage. So the burden on the circuit breaker contacts decreases. High frequency restriking voltage transient produced at the time of switching off of the inductive or a capacitive load and are damped. Transient recovery voltage is distributed equally across the contact gap in multi-break circuit breaker. The post-zero resistance, that is the after the fault current quenching, the contact space, the post-zero resistance of the contact space is low in plain break circuit breaker. So resistance switching is not needed in that case. But in case of air blast circuit breaker, the value of the post-zero resistance is more compared to that. So the voltage transients are produced due to the current chopping, and hence the resistance switching is employed for the air blast type circuit breaker. So this is how the resistance switching in circuit breaker can be understood. Classify circuit breakers on the basis of interrupting medium. So on the basis of interrupting mediums, circuit breakers are classified into these 5 categories. First is air circuit breaker, oil circuit breaker, air blast circuit breaker, sulfur hexafluoride circuit breaker, that is SF6 circuit breaker, and last is vacuum circuit breaker. So these are some types of circuit breakers which are used on the base in the power system and are classified on the basis of interrupting medium. Brief introduction of oil circuit breaker. So in oil circuit breaker, insulating oil is used as the quenching medium. The contacts are immersed in the oil. The contacts are separated when the fault occurs and the arc is produced across the contacts. So due to this, the heat of the arc, the oil is decomposed and mainly the hydrogen gas is produced in large quantity. Volume of the gas is about 1000 times that of the decomposed oil. So the hydrogen gas around the arc pushes the arc product away from the contacts and arc quenches by the two processes. First is the heat conductivity of the hydrogen is much high, so arc gets cooled down and the deionization of the medium becomes rapidly fast and so the arc quenches quickly. In the second type or the second process, the turbulence are produced due to the hydrogen gas. So oil sprayed in the space between the contacts and this oil is forcing the products or the arc products away from the contacts, and due to that the arc products are pushed away from the contacts and arc quenches completely. So this is how the oil circuit breaker quenches the arc. So this is the basic or the brief introductory information of oil circuit breaker. Advantages and disadvantages of oil circuit breaker. So advantages are energy of the arc is absorbed by the oil and the hydrogen gas having very good cooling properties produced and results in rapid arc quenching. The absorption capacity is very high in case and the arc quenching is fast. So oil possesses insulating property, so less clearance is required between the live conductor and earth. Oil works as the cooling medium and after current zero, oil with high dielectric strength goes into the space between the contacts and quenches the arc easily and effectively and in less time as compared to air circuit breaker. The limitations of oil circuit breakers are explosive mixture of gases is produced when the oil decomposes and carbon is produced due to the decomposition of oil which decreases the dielectric strength of the oil. So periodic checking and filtering or replacement of the oil becomes necessary. Oil is highly inflammable. So these are some limitations of oil circuit breaker. Classify oil circuit breaker. This question is asked many times in the examination for 2 or 3 marks. So oil circuit breaker is classified in basically 2 types. First is bulk oil content type circuit breaker and second is minimum oil content type circuit breaker like BOCB and MOCB. In bulk oil circuit breaker type, it is classified into 2 types. First is plain break type and another is arc controlled type. In case of plain break type, there are 2 types of circuit breaker. First is single break type and another is double break type. Whereas in case of arc controlled type, there are 2 types of circuit breaker construction. First is self blast or self-generated pressure type circuit breakers. Another is forced blast or externally generated pressure type circuit breakers are there. Again, self-blast or self-generated pressure type circuit breakers are classified into 3 categories. First is plain explosion pot, second is cross-jet explosion pot, and last is self-compensated explosion pot type. So this is how we can classify oil circuit breaker and this arrangement is made a chart type so that you can remember very easily and effectively. Give brief introduction of bulk oil contained circuit breaker. So in this type of circuit breaker, the quantity of oil is in a large amount, hence it is termed as the bulk oil contained circuit breaker. There are two functions of oil. First is to quench the arc and the second is to insulate the live part from the earth. There are two types of construction of this type of circuit breaker. One is plain break circuit breaker and second one is the arc controlled circuit breaker. So in the first type, no external device is used to control the arc. The arc is controlled naturally by the pressure due to the head of the oil above the contact level. There are two types in this. One is the single break type and the second one is the double break type. And in arc control type circuit breaker, the arc is controlled by different methods. In that, in a self-blast or self-generated pressure type, the arc is controlled by the pressure produced due to the energy of the arc. There are three types in this. First is plain explosion pot, second is cross-jet explosion pot, and third is the self-explosion pot. In a forced blast or externally generated pressure type, the pressure is generated by the external device. So this is the introductory information of bulk oil contained circuit breaker. Give brief details on plain break oil circuit breaker and state its types. So in this type of circuit breaker, there is one earthed tank available. It is of a big size. Fixed and moving contacts are placed in it. So and oil is filled up to some level above the contacts and the remaining top part is kept empty for the decomposition of oil, and due to this decomposition of oil, the gas forms and they are going in upward direction, and this works as the air cushion at that time. When the arc is produced, high pressure is not produced due to the decomposition of this oil. There are two types of construction in this type of oil circuit breaker. One is single break oil circuit breaker and the other one is the double break oil circuit breaker. Explain constructional details of single break, plain break oil circuit breaker. So in this, a strong steel tank forms the outer body of the breaker and it is partly filled with the insulating oil which is known as the transformer oil, which is earthed or grounded to provide the safety. Whenever we touch the body or outer body of the tank, we should not get the shock. Fixed contacts are located inside the tank, firmly supported and immersed in the oil. They are made up of copper or copper alloy for good conductivity and connected to the external circuit through bushings available on the outer body of the top cover of the outer body. A copper rod or a tubular contact that can slide in and out of the fixed contact serves as the moving contact. It is operated by an operating mechanism placed outside the tank, connected through an insulating rod. When closed, it fits snugly into the fixed contacts, ensuring low resistance path and hence the current can easily flow through it. Porcelain or composite bushings are mounted on the tank cover. They carry the current carrying conductors through the grounded tank without leakage. So the fixed contacts are mounted under the bushings like this. Oil fills the tank up to a certain level and leaving some space above the tank level or the above some level of the oil because the tank is partly filled and some part is serving as an air cushion for gas collection. When the arc is struck, the oil decomposes, releasing hydrogen gas which helps in cooling and deionizing the arc. A mechanical or solenoid based operating mechanism mounted outside the tank. It is connected to the moving contact via an insulating operating rod. It is responsible for the quick opening and closing of the breaker. Tank cover is bolted and sealed to prevent the oil leakage. Also provides mounting for bushings and operating rod entry. So this is how the constructional detail of a single break, plain break oil circuit breaker. Explain the working of single break, plain break oil circuit breaker with figure. So you can visualize in the figure. Here we have the single break, plain break oil circuit breaker. In this, a transformer tank is partly filled with the insulating oil. You are visualizing this, and this oil is your transformer oil. In the normal condition, the moving contact remains engaged with the fixed contact. Here it is. Moving contact engaged with the fixed contact. In inside the oil and current flows through the contact without any interruption. From this, current entering and these contacts are fixed and current leaving from this. So this is how the current flows in entering and current leaving. Now during the fault condition or opening operation, the protective relay gives a trip signal to the moving contacts to the circuit breaker strip coil, which operates the trip coil, energizes the breaker contacts, and the moving contact separates from the fixed contact. Under this action, the operating mechanism operates and the fixed contacts and moving contacts are separated like this. As the contacts separate, an arc forms between them inside the oil. The high temperature of the arc decomposes the oil into the gases, mainly hydrogen, methane, and ethylene. The hydrogen gas forms bubbles around the arc and exerts the cooling and deionizing effects. Due to these two types of actions, the arc cools and increases the dielectric strength of the surrounding medium. The arc finally extinguishes at a current zero, that is natural current zero instant. After the arc is quenched, the contacts remain separated and the circuit stays open. The oil also provides insulation between the live parts and the grounded tank. So this is how the working of the single break, plain break, oil circuit breaker can be understood. Explain constructional details of double break, plain break, oil circuit breaker with a proper figure. So a strong steel tank forms the outer body of the breaker, which is partly filled with the insulating oil, which is serving as a transformer oil, which is earthed or grounded to provide the safety. So the operator may not get shocked when touched due to the leakage current flowing through the outer body. Porcelain or composite bushings are mounted on the tank cover and they carry the current carrying conductors through the grounded tank without any leakage. Two fixed contacts are placed inside the tank, one at each end. Both are immersed in the oil and connected via external link through the bushing. So here you can visualize this. This is the tank or the outer body and it is partly filled with the insulating oil, that is a transformer oil. And these are two bushings from which the current entering through this and current is leaving through this. These serves as the connection of the fixed contacts. Here they are fixed contact and this mechanism, operating mechanism, and these are the moving contacts. Now, two fixed contacts are placed inside the tank, one at each end, and both are immersed in the oil and connected to external lines through the bushings. So here they are connected via bushings. These are the fixed contacts. You can visualize this. Now, a single moving contact rod is provided. So this is the single moving contact rod is available between the two fixed contacts. During the closed position, it bridges the fixed contact. So during the closed position, this contact is fixed in this and this in this. So this is forming like closed contacts and allowing the current to flow during the normal operating conditions. So current will flow through this, entering and leaving like this. So now when the opening comes, when the fault occurs, the breaker is energized via relay. The moving contact withdraws from the fixed contact and it comes out of the fixed contact, and due to this the contact separation takes place and two contact gaps are formed, one at each end. You can visualize this is the contact gap, and the operating mechanism is located outside the tank and connected to the moving contact via an insulating operating rod. Now whenever these contacts are separated, the arc strikes in between, and this arc, having a very high energy, decomposes the oil in the surrounding medium, and due to this the hydrogen, methane or ethylene type of gases are generated and they move in upward direction and are collected in the air, and this serves as the cooling purposes and deionizing the arc path, and so the medium dielectric strength improved and arc gets quickly quenched. So this is how the constructional detail of a double break, plain break, oil circuit breaker. Explain working of double break, plain break, oil circuit breaker. So as per the construction, it is having two different porcelain insulators supporting or the bushing supporting the two conductors, and a central insulating rod is connected which operates the moving contact. So during the normal condition, the moving contact bar bridges the two fixed contacts inside the oil tank. Current flows from one line bushing to fixed contact to moving contact to other fixed contact and through the other line bushings. Now when a fault occurs, the protective relay energizes the trip coil. The operating mechanism pulls the moving contact bar away from both the fixed contacts simultaneously, and this creates two different breaks, and due to this the arc creates because of the contact separation, one at each end of the moving contact. Now as the contacts apart, two arcs are formed in series inside the oil, and the arc decomposes the surrounding oil, producing the gases, mainly hydrogen, methane and ethylene type gases. The high pressure hydrogen gas bubbles form around the arc, having cooling effect which lowers the arc temperature, and deionizing effect that increases the dielectric strength of the medium, due to which arc extinguishes quickly. Now because there are two arcs in series, the total arc voltage is double compared to a single brake type plain brake oil circuit breaker. This helps in faster and more reliable arc extinction. Now at a natural current 0 of AC, the arc is extinguished. The surrounding hydrogen gas restores insulation strength rapidly, and the circuit remains open, preventing fault current from flowing through the circuit. So this is how double brake plain brake oil circuit breaker works. Disadvantages of plain brake oil circuit breaker. So there are several disadvantages of this type of oil circuit breaker. Some of are listed over here. A large amount of oil is needed both for arc extinction and insulation purposes. So this increases the size and weight of the breaker. During the arcing, oil decomposes and produces gases like hydrogen, which are highly explosive and inflammable and cause fire hazards. The oil gets contaminated due to the carbon particles formed during the arcing, requiring regular inspection and replacement. The arc extinction process in oil circuit breakers is relatively slower compared to modern types like SF6 or vacuum circuit breakers. Frequent operation causes faster deterioration of oil quality and contact erosion. The overall design is bulky and heavy, making installation and transportation difficult. Arc quench wire increases the length of the arc through insulating rod only. Due to this, the arc length increase control, the time of operation or the arc quenching is very high. So arcing time increases. So these are several disadvantages of plain brake oil circuit breaker. Advantages of plain brake oil circuit breaker. So there are several advantages of this type of oil circuit breaker. One is the design and construction are simple, making it easy to manufacture and operate. It provides reliable interruption of current under moderate fault conditions due to the cooling efficiency of oil. Here oil serves both purposes. First, it serves as an arc quenching medium, and second as an insulating medium between live parts and earth. So oil is only the necessary medium for quenching as well as insulation. The oil absorbs heat produced during the arcing, helping in cooling the contacts. It can be used for medium to high voltage systems due to good dielectric strength of the oil. The cost of the construction and installation is comparatively lower than the modern circuit breaker. So these are some advantages of plain brake oil circuit breaker. Provide basic details of arc control type oil circuit breaker. So there is no arrangement of control the arc in the plain brake type oil circuit breaker, but the arc is quenched only by increasing the length of the arc and by the turbulence produced by the oil itself. But this requires more time to quench the arc, so it is necessary to control the arc by some other method if the time has to be reduced. Such type of breakers are known as arc control type circuit breakers. There are two types of these breakers. One is self-blast oil circuit breaker or self-generated pressure oil circuit breaker, and second is forced blast oil circuit breaker or externally generated pressure oil circuit breaker. So this is the basic detail of arc control type oil circuit breaker. Share basic details of self-blast oil circuit breaker. So a self-blast oil circuit breaker is a type of oil circuit breaker in which the energy required for the arc extinction is obtained from the arc itself. In this type of circuit breaker, the arc is controlled by the pressure generated by the arc itself. For this, pressure chamber is provided around the contacts. Pressure of the gas produced becomes very high as the size of the chamber is very small. Oil and gas go to the arc space and quench the arc. In other words, the pressure needed to drive oil for the quenching the arc is developed automatically by the heat of the arc without any external mechanism, and hence it is termed as self-blast oil circuit. Explain working principle of self-blast oil circuit breaker. So when the circuit breaker opens, an arc is struck between the contacts, that is the arc is struck between the fixed contact and moving contact. The heat of the arc vaporizes the surrounding oil and forming high pressure gas, mainly hydrogen, and along this ethylene, methane, etc. hydrocarbon gases are produced inside the arc control chamber. This high pressurized gas is directed through a nozzle across the arc path. The blast of the gas and oil vapor rapidly cools and stretches the arc, causing it to extinguish at the current zero interval. Since the pressure is developed by the arc energy itself, the breaker is termed as self-blast oil circuit breaker. So this is how the self-blast oil circuit breaker works. State advantages of self-blast oil circuit breaker. So there are several advantages of this type of breaker. Some of are, so first is no external compressor or pressure system needed because the arc is quenched by the energy produced by the arc itself and a pressure chamber is available within the breaker itself. Breaking capacity of this type of circuit breaker is very high or moderately high. Simpler and more compact design compared to the forced blast types breakers where the external pressure system is required. Efficient arc extinction due to the high gas pressure near the arc contacts or the arc chamber. Suitable for medium to high voltage applications. Arcing time is less compared to the plain brake oil circuit breaker. So these are several advantages of self-blast oil circuit breaker. State disadvantages of self-blast oil circuit breaker. So there are several disadvantages of this type of breaker. Some of are discussed over here. The arc decomposes the oil and forms carbon deposits, which reduces the dielectric strength of the oil. So frequent oil filtration or replacement is required. Now the oil is inflammable and the gases formed during the arcing, mainly hydrogen, can cause the explosion or fire in case of leakage or fault. Regular inspection, cleaning and oil testing are necessary, making it less suitable for remote or unattended type substations. It cannot handle very high fault current effectively compared to force blast, SF6 or vacuum type circuit breakers. Even though it uses self-generated pressure, it still requires a considerable amount of oil for insulation as well as cooling purposes. Continuous arcing leads to chemical decomposition of oil, producing sludge and gases that affect its performance. The pressure generated depends upon the magnitude of the fault current, so it becomes very difficult to design such type of breakers. It is heavier and less compact than modern type of circuit breakers that we are using. So these are several disadvantages of self-blast oil circuit breaker.